luminosities in terms of the solar luminosity. Okay. So L sun. Ooh, and also we have a different sort of luminosity that we estimate for the disk of our galaxy versus the bulge versus the halo versus the grand total. So the grand total, let me just read it off actually. The disk we think is 19 times 10 to the 9 solar luminosities. Okay, yeah. Let us know when you're back and keep following the discussion. Actually, I kind of want some food too. The bulge is 2 times 10 to the 9 solar luminosity. The halo is also around estimated 2 times 10 to the 9 solar luminosity. So this is like 2 times or 2 billion solar luminosities. And the grand total is something like 23 billion solar luminosity. So now we will estimate some things. So our galaxy's total luminosity of 23 billion solar luminosities is fairly bright. Pretty bright. Like our galaxy is not one of the smaller, dimmer galaxies. It's a pretty, kind of like a pretty substantial big galaxy actually. So it's fairly bright. As galaxies go, if all the stars in the Milky Way galaxy were identical to the sun, which they're not, then we'd conclude that our galaxy contains 23 billion stars. So if we thought that every star was like the sun, and we estimated a 23 billion solar luminosity type of luminosity, then we would say, well, there are 23 billion stars. But actually, remember, we talked about the sun in some depth at one point, and we saw that the sun is actually pretty young, and it's on the main sequence part of its evolution. So there are going to be stars that are older or, more sort of like still forming, etc., etc. So most stars are actually dim little M dwarfs. So there's a type of star, M dwarf, that contribute little to the total luminosity, particularly in the B band. So the best current estimate, so taking into account the fact that our sun is a young sun, pretty bright, pretty spectacular in that sense, the best current estimate is that our galaxy actually contains 200 billion stars. So given that our total luminosity is 23 billion solar luminosities, we think that our galaxy, just the Milky Way galaxy, has 200 billion stars. So yeah, I don't know if Star Wars has been telling you that you can like go to other galaxies and go to other planets and their stars. I mean, exoplanets is something that we search for, but even that is very difficult, even within our own galaxy. But regardless of what Star Wars encourages, there's a lot indeed to explore, and it can be a little mind-boggling, the numbers, when you fact check the reality of the situation. So our estimate of the amount of stars is based on the galaxy's luminosity. Yes, galaxy's luminosity as a whole, and a little bit about the different parts of the galaxy too, and where we think what happens. So we'll get into that in a little bit here. So we don't think that star formation is equally active everywhere in the galaxy. So there are certain things like that too. So, oh, we got 10 likes. Thank you so much. Thank you for 10 likes. Can we get 20 likes? So if you could view the Milky Way galaxy from outside, which we can't easily, I mean, maybe we can in Star Wars, oriented so that the disk were edge-on, it would probably look like the galaxy NGC 891 that we just looked at, that edge-on one. And we saw that there was a prominent dust lane running down the middle of the galaxy. It is generally true for disk-dominated galaxies like the Milky Way and NGC 891 that the gas and dust is confined to a much thinner disk than the stars. So there is some things that we think about the gas and the dust and where that is, and we think that those are in a thinner disk, and then there's thick disks, and those are where maybe more of the stars are. I know, I'm so hungry too.